Hey, this connected construction tip is about finding the flatness of a floor, regardless of levelness, with an X9 laser scanner. And instead of using Field Link, which you can kind of do this with a user-defined plane inspection, we're going to be showing how to do it in RealWorks because there's a few more tools there to do it. We also have another video on user-defined planes that you can review. So here you can see we have a very sloped parking garage. We can actually create a plane and best fit for that to see the contours of where that's higher and lower. We're actually be doing it on a flat floor and then showing you how to share that via Connect so that we can see the high and low spots for that, as well as communicate that to the grinder somewhere we need to fix it. Hey, Steve Trimble. In this connected construction tip, we're going to show you how to do a best foot plane for floor flatness because we don't really care about levelness when the floor is elevated. We just want to make sure it's flat. So if we put down tile or keep it exposed, it's not super bumpy. So here you can see red is high, blue is low. If we open this up, you can actually start to see what it looks like here. So this is probably going to be finished. We can see here, this is where the floor is. If I click doing the elevation, I can see from here to here, we have a 0.13 foot, which is about 2-inch difference between those two. And the distance between that point selected in here is 21 feet. So more than likely, we're deviating more than 3/16 of an inch or 3/8 of an inch, which is usually over 10 feet what you want to do or want to be within. So that's what it looks like. You can see from here to here is 11 feet, and we're almost at 1 inch deviation. So how do we do that? Kind of have two different deliverables that we can do. We can do and we're going to copy this real quick. Copy. We can do a cloud-based modeler. And what this will do is fit a plane to that, essentially to the best fitting of that plane to create. And we'll actually copy that, delete the geometry here. And what we did was we created a plane. We now have a plane and the same scan data. We can do a surface to model inspection. And we'll do a 0.5 resolution, display cloud, and we'll preview that. So here is still telling me it's high to that best fit and low. If I go to the inspection map analyzer, we can then create contours, which will not be to the Z elevation, but to that plane. Let's change this actually to inches so that we know what we're looking at. So there's 3/8. Anytime those contours are within 10 feet for 3/8 of an inch, if I want to keep it flat to that, that's where we'd want to grind and or fill. So this area you probably want to fill. And these areas we would need to grind. We're going to show you another way to estimate that too. But these contours, if I look at it from the side, you can see it kind of goes with the plane there. It's not completely flat. It's to the best fitting of the plane that was there. So we'll create those contours. And here, those contours are nice. Create the map too, just so we can show you. Turn the map off. And turn off that guy. So there's that one. Here's our ISO curves. Anytime these contours are, again, within 10 feet, that means that it's dropping more than 3/8 of an inch within that. So here we would not be that good. Probably need to grind wherever that orange and yellow is, and then fill where the blue is. So here to here is probably well less than 10 feet, which it is. So I can easily map that and say, let's grind this area with the contours and share that via Connect, which we'll show you in a second. But there's another way to do an estimate that I wanted to share as well too. So with this, I'll share the contours, but I can also do a volume calculation and do a similar plane best fit to the data there. So we'll do everything that's there. Again, looking at it from the side there, you can see here's where we're high with that plane not being aligned because it's best fitting to the point cloud that is there. So we're happy with that best fit. We'll do that one more time, make sure we're there. So I'll do best fit. Close the tool. And then do a resolution of 6 inches and preview it. So this is going to tell me the amount of square feet in volume for cut and or fill. And if I adjust this, let's say I want to actually add more fill because it's more label intensive, we'll do that not at 0.1, we'll do 0.5. I can essentially move that plane up, and now I have more fill than I do cut. So I can kind of figure out exactly whatever makes sense financially to either cut or fill if it's cheaper to add more RDEC than it is to grind. It gives me that as well too. So I can create a report with that and save it as an RTF. So cut fill, FF cut fill. And I have a pretty good estimation of where I need to cut and where I need to fill within that. But we'll create this and share this via Trimble Connect so I can actually tell my finishers, hey, compared to the model, this is exactly where we want to cut and fill. So I'll upload that and then show it to you here in a second. So here is that data uploaded to Connect. You can see we have the scan data, which with the new release of RealWorks 2026, we can actually export directly to Connect. As well as if we turn that off, that's going to show you an elevation mode that we have here. But what we can also see are the contour maps of where that's at. And then I've actually brought over the field link points, so we can kind of use that too as needed. That'll do a sample of it. So from here, I can come in here and actually tell the finishers with a cloud or even with a text markup. Grind here. Let me take this off a little bit and then put a text markup here for filler. I can't spell RDEC. So now I have that. I can actually send the reporting to that I made in RealWorks for how much leveling I need to go, or how much leveling I need to order, how much grinding needs to be done with this mapping out either to a 2D plan or to a 3D plan like you see here, where that needs to be grinded. And if I save that as a view, the finisher is going to see that we need to grind here, grind back here, to keep it flat rather than just staying with the elevation mode. So thanks, and please reach out to your nearest building point partner if you have any questions.